All right, so midsegments and inequalities of triangles. This is day 11. So a midsegment of a triangle is a segment connecting the midpoints of two sides of a triangle. I know. For example, if I look at this triangle down at the bottom, I have side AB. In the middle of side AB, I have D. I know that D is in the middle because this is marked congruent to this. So AD is marked congruent to DB. So D is the midpoint of that side. If I look over on this side, if I look at side BC, I know that E is in the middle because BE is marked congruent to EC. So since I have two sides that have midpoints, D and E, then the mid segment is the line that connects those 2 points. So line DE, or line segment DE, is the mid segment of this triangle. Also note that your mid segment here is parallel to the side that's not involved. Like these DE is parallel to AC. So there is a triangle midsegment theorem. If you have a segment connecting the midpoints of two sides of a triangle, it's parallel to the third side and half as long as that third side. So here we have midsegment TR. It's half as long as the segment that it's parallel to YZ. So if I take YZ, say YZ is 10, then I would know that TR is half of that, which is 5. The opposite's true. If I know that TR is 5, and I want to know what YZ is, I would multiply it by 2, because now it's twice as long, which is what that down here says. If you're given the length of the mid segment, then you multiply it by 2 to get the outer parallel side. So if we look at this question here, we're asked to find the length of the mid segment. Here's my mid segment. I know the outer side. So do I multiply that by 2 or do I divide it by 2? Divide it by 2. So if I take 46 and divide it by 2, I get 23. I want you to try the next one. So this time I've moved the 46 to the middle. So the length of the base is 92. So these are pretty straightforward, but we always like to make things more challenging, right? So we're going to add some algebra into it. Oops. So here we were given information about the mid segment and the side that it's parallel to. There's 2 ways you can do it. You can take the inside, the mid segment, and you can multiply it by 2 so that it equals this one. That's the way I suggest doing it. So 2 times 5x minus 1 would equal the side that is parallel to the 6x plus 10. The other way you could do it, you could take half of the parallel side. So you could take 1/2 times 6x plus 10 equals the mid segment 5x minus 1. So either one of these you could use, but a lot of times students don't do this one because it's got that fraction in it. So if we can avoid the fraction, we're going to. So 2 times the mid segment, so 2 times 5x minus 1 is going to equal 6x plus 10. So just a basic algebra problem, we're going to distribute to get rid of our parentheses.
Wait, which one are we solving for? The top or the bottom?
We're doing the bottom one because it doesn't have a fraction in it. So you could do the top one, it just has that fraction in it. We're doing the bottom one just because it doesn't have a fraction. You'll get the same answer for both of them. Subtract 6x from both sides, so 4x minus 2 equals 10. Add 2 to both sides, so 4x equals 12. Beside it, divide it. So divide by 4, and x equals 3. Unfortunately, my instructions did not ask me to find x. They asked me to find the length of the midsegment and the base. Yep, so now we just get to plug it back in. We get to plug it back in 2 different places to get 2 different answers. So for the midsegment, we're going to take 5 times 3 minus 1. Well, 5 times 3 is 15. Minus 1 is 14. So your midsegment is 14. If I plug in 3, 6 times 3 plus 10, 6 times 3 is 18, plus 10 is 28. Keep in mind your base should always be twice as big as your midsegment. So if I take my midsegment that's 14 and multiply it by 2, I could have also got that the base was 28. So just another way of doing that.
Can I just put like mid?
Mhm. Sure. Questions on this one? Here we were given a pretty complex diagram. We were given a big triangle EFG, so that's the biggest triangle, but then we're told that H, J, and K are midpoints. And then we're asked to find 3 of the sides involved. So looking at the first one we're asked to find, first thing we're asked to find is HJ. So we're being asked to find this right here. So we're being asked to find a midsegment. Do we know the base? So the base is the line parallel, which is 100. How do I get the midsegment from the base? Divided by 2, so HJ is equal to 50. The next one asks me to find JK. Well, if I look at JK, JK is in the middle. It is another midsegment. It's right here. What is the base to JK? So keep in mind the base isn't necessarily the bottom in this case. It's whatever JK is parallel to. So JK is parallel to EF, which is 60. Do I want to multiply that 60 by 2 or divide by 2? Divide. So 60 divided by 2 gives me 30. Remember, you always divide the outer number to get the one on the inside. And then last one, we're being asked to find FG. FG is out here. So it's that entire right-hand side of our triangle. Do I know the midsegment that's parallel? Absolutely, it's 40. So if the midsegment's 40, what's the base? 80, perfect. Questions on this one? The next one, if AB equals 10, I'm going to go ahead and label AB 10. CD is 18. And then we're asked to find EB, BC, and AC. EB is definitely 9, so that is the mid-segment to CD. That's 18, so half of 18 is 9. What do you know about BC?
It's parallel to
Those are congruent marks.
congruent.
So it's congruent to what? It's congruent to AB. What's the measure of AB? 10. So what does the measure of BC have to be? 10.
And then AC would be 20.
Absolutely. So AC would therefore be 20. If I had to walk from A through B all the way to C, 10 plus 10 would be 20.
So what are the single lines mean?
So these single lines mean that AE is congruent to ED. So this is just meaning that this segment from end to end is congruent to this segment end to end. So this is congruent to this, and since this has 2, it's congruent to the other 2. So they always, we always start with 1, so this is congruent to this, and then anytime you go to another one, 2, you can have 3, you can have 4. Normally we don't get past 3. The next one in the diagram, DE is the mid-segment of triangle ABC. Find the values of X and Y. Take a minute and see if you can find X and find Y. All right, what'd you write for X? 14, absolutely. 14 is, or X is the base of the mid-segment, which is 7. 7 times 2 gave us that 14. What about Y? 5. So we know since DE is a mid-segment that this must be the middle, which means that AD is congruent to DB, so they both must be 5. And then the tricky question. So here we were given that DE equals X plus 2. DE is our mid-segment. I know that DE is my mid-segment because the right side has a congruent mark above and below it for letter E. So E is a midpoint. And then D is a midpoint because both segments that it creates, above it and below it, are marked congruent. So I'm going to go ahead and label DE as X plus 2. And then BC is 1/2 X plus 19. We're being asked to find DE, which first means we got to figure out what X is. So to figure out what X is, I'm going to start with 2 times my mid-segment. And that's going to equal the base. So I'm going to go ahead and multiply to distribute the 2. I want to know how many of you like fractions.
I prefer decimals.
So we actually don't even want to get a decimal in this. We just want to get rid of that fraction. To get rid of any fraction, you can always multiply by the denominator. So the denominator is just the bottom number. So we're going to take every single term, all the way from the left, all the way to the right, and we're going to multiply it by that denominator of 2. So all the way across both the left side and the right side of my equation. So 2 times 2x is 4x. 2 times 4 is 8. Then my equal sign. 1/2 x times 2. Well, the 2's are going to cancel, leaving you with 1x, or just x, plus 38, because 19 times 2 is 38. That look better? So no fractions, no decimals, numbers, whole numbers that we can deal with fairly easily. So I'm going to subtract x, that gives me 3x plus 8 equals 38. Subtract 8, so 3x equals 30. Beside it, divide it, and x equals 10. Does that answer the question we were being asked? No. So we were being asked to find DE. Do we have enough information to find DE now?
Yeah.
Yeah. So we know that DE is equal to x plus 2, but we know that x is 10. Whoops. And 10 plus 2 is 12. So actually our final answer to this problem isn't that x equals 10, it's that DE equals 12. So that's pretty much it on mid segments. There is some algebra we can add in like this. And now we're going to move to some triangles. So if I gave you this diagram, do you think we can make a triangle out of these three sides? No, you don't think so? If I move that down, if I just tilted it down, if I move both sides in, it can make a triangle. So yes, this one can. What do you think about this one? Whoops. No, this one's definitely a no. Oh, there's my box again. So this one's impossible for you to make a triangle out of. There's no way I can move those two sides so that they'll reach each other in the middle. So C and D can never get to each other. They're not long enough. So we're going to look at the triangle inequality theorem to see how we can make triangles and what's required for side lengths so that you can make a triangle. So the triangle inequality theorem tells us that the sum, so we're going to add the lengths of any two sides of our triangle, and it has to be greater than the length of the third side. So in this diagram here, if I added side length A, little a, to side length little b, it's got to be greater than this third side, or it won't work. So that's a plus b must be greater than the third side, C, and we could pair any of those two sides together. I could do a plus c's got to be greater than b, and b plus c's got to be greater than a. So whatever two sides you're given must be greater than the third one. So given a triangle with side lengths 3 and 7, we need to find the range of the possible values for your third side. So for our minimum value, x has to be less than the 3 plus the 7 that we were given. So it can't be any longer than that, or if I move this any further, they're not going to be able to reach. It's actually going to be a flat line on top of a flat line, which isn't going to create a triangle. And then your minimum value, if you subtract them, 7 minus 3 gives us 4. So your x values have to be greater than 4, which means I can have any x value for that side length that's between 4 and 10. So if I want to create a triangle, the third side length must be between 4 and 10. Can't be greater than 4, can't be equal to 4, and can't be equal to 10. So we're going to take the difference, we're going to subtract our two numbers to be less than the third side, which is less than the sum when we add them together. This looks like a lot, but I promise it's not. So determine if the following side lengths could form a triangle. So we're going to write ourselves an inequality to prove that. So remember, any two sides must be greater than the third. So I'm going to just pick these two sides. Is 8 plus 17 greater than 20? So you get 25 is greater than 24, which is true. So when we do these, we always want to pick the smaller two numbers to add together to check to make sure it's greater than a third. So when we, actually question 2 is already kind of set up that way. So our two smaller numbers, we're going to take, 3 plus 3 and see if it's greater than the third side, which is 7. Well, we know 3 plus 3 is 6. Is 6 greater than 7? No, so this would not form a triangle.
I thought you could change the thing.
So we got to take the two shorter sides and make sure that they're longer than the third side. So when we do question 3, we want to do these two numbers together and make sure that when I add those two together that they're longer than 35. So 25 plus 12 must be greater than 35. Well, 25 plus 12 is 37. 37 is greater than 35. So this checks. This is a possible triangle. Number 4, 37 plus 42 should be greater than 52. Let's see, 79 is greater than 52, which is a yes. So take a minute and see if you can do questions 5, 6, 7, and 8.
What if they're equal?
They cannot be equal. They have to be greater than. You want question 5? So question 5, you get 50 is greater than 50. 50 is not greater than 50. 50 is equal. Oops. So this is a no. 50 is not greater than 50. If you've got $50 and I've got $50, I can't say that I've got more money than you. We have an equal amount of money.
Okay, so I watched this YouTuber, and she looks a lot like Mackenzie, and even sounds a lot like her. And it's really weird.
Question 6, I'm going to add 6 and 14 together, get 20. 20 is greater than the longest side, 18, so that does form a triangle. Question number 7, I'm going to add the two shorter sides together. 12 plus 11 is 23. That is not greater than the third side, which is 24, so that does not form a triangle. And then the last one, question number 8, two shorter sides added together. 7 plus 35 is 42. 42 is greater than 41, so yes, this does form a triangle. Here we're going to find an inequality that represents the possible values of the third side. So we're given two sides of a triangle. We're going to set up an inequality using the sum and the difference to show the range of possible side lengths for the third side. So we're going to subtract. We're going to use x as our third side. So we're going to subtract to find the left number, add to find the right. So this is our difference and our sum.
There's a lot adding and subtracting.
Yes, a lot of adding and subtracting
I feel
today.
like I'm back in elementary school.
So all of these problems are going to have these symbols in the middle. So some number is less than x and it's less than some other number. To get these two numbers, I'm going to take the difference. So I'm going to subtract my two numbers on the left. I'm going to add them to get the numbers on the right. When you subtract, it doesn't really matter to me if you take 22 minus 14 or 14 minus 22. But if you take 14 minus 22, you're going to get negative 8. Is it possible to have a side length of negative 8? No. So you're just going to write positive 8. So never write a negative number. It doesn't matter how you subtract and just write the positive version of whatever you get. Because 22 minus 14 gives me 8. Then if I add them together, 14 plus 22 is 36. So I know for these two sides to be a triangle, I need to pick the third side length to be between 8 and 36, but I can't pick exactly 8 and I can't pick exactly 36. I could pick 8.5. I could pick 8.00000001 if I wanted to. It would become a triangle with those values. Let's try another one. Question 10, 31 and 28. So again, my symbol's less than x less than, and I've got to fill in the subtraction on the left, addition on the right. So 31 minus 28 is 3. 31 plus 28 is 59. So any number between, but not including, 3 all the way up to 59, not including 59, would create a triangle. So any number that I could pick, so I could pick 12, I could pick 22, I could pick 51, I could pick 58.999. All of those would form a triangle with the two sides we were given. So 3 and 11, I'm going to take 11 minus 3 to get 8, 11 plus 3 to get 14. So my side lengths and then that 19 plus 45 is 64. Take a minute and see if you can do the 2 at the bottom. So for question 13, when I subtracted, I got 17. When I added, I got 31. So my x values, or my third side, must be between 17 and 31. Question 14, when I added them together, I got 25. When I subtracted them, I got 9. So the third side has to be somewhere between 9 and 25, or I cannot form a triangle like I want. Questions or concerns?